Hello everyone, thanks for coming. I'm Matthew Allum, and I'm going to talk about Clutter. Clutter is a library for creating user interfaces on top of OpenGL and OpenGL ES. As well as using OpenGL, it also uses gobject, glib, pango, and GDK pixbuff. It's for the creation of very animated, visually impressive, bespoke, whatever user interfaces. It has a very raw but flexible API. You can think of it sitting like somewhere like above GDK but below GDK. It shouldn't be considered as like a general interface to OpenGL, though you can do 3D stuff with it. We kind of like to think of it as for creating 2D interfaces with kind of like 3D effects. It's written in C, it's LGPL licensed, and we recently released 0.31. We created Clutter, seeing like OpenGL on desktop systems becoming pretty much commodity nowadays, and also the emergence of GPUs on like embedded devices and OpenGL ES. We wanted like a simple UI that a simple API that didn't involve needing to know like the GL API or the maths involved, that kind of thing. And also we wanted like object orientation and also like windowing and eventing abstractions. Also it was a chance for a bit of fun and experiment and see what we could do and how we could make that kind of thing work. So the obvious kind of use case for it is for media boxes, things like Microsoft Media Center and Apple's Front Row. Other things include like add-ons to like regular GTK applications, things like cover flow, like the cover flow effect in iTunes, and also like a picture viewer in like a photo program, whatever. Also, you know, there's a lot of uses for it in embedded. If you look at things like the Zune UI and the iPhone, all them kind of things using GLES to provide very like visually impressive UIs. It's not for creating games like Quake, although maybe you could do it, and not for creating like desktop applications like spreadsheets. You probably could do it, but you know it probably wouldn't be a good idea. Okay, so general concepts in Clutter. Everything's known as an actor, which is basically the same kind of thing as a widget in GTK. You add actors to the stage being the window. Actors can have parents. Well, no, sorry, all actors have parents, but they can also have children. And actors are manipulated directly via events or animations. Okay, and every single actor can be positioned in 3D space, rotated around 3 axes. Obviously size, scaled, have its opacity set, and also be clipped. Also, when you apply one of these transforms to an actor, it also applies to all its children. So that also means that position is also relative to its parent. Okay, so here's a simple example. You can see we initiate Clutter with the Clutter in it. We get the default stage, which is just the window. We open up a pixbuff. We create a Clutter texture from that pixbuff. Then we add the actor to the stage, position it, rotate it, show it, and then drop to the main loop. And I can show you that in action. So you can see I've just loaded in a pixbuff and rotated it 180 degrees. And then, so I spoke about actors having children and the transforms also applying to them. Like the simplest kind of composite actor is a group. It does no layout, it just groups actors together. You can see I create 2 actors this time. I add them to the group. I set their positions relative to the group. Then I set the position of the group, and I rotate the group rather than the actor itself. And you'll see that. You'll see there I have 2, but they're rotated around the center of the group rather than the center of the center of themselves. And yeah, hopefully that gives an idea of how you kind of build up user interfaces. It's pretty simple, pretty free, you know. But of course there are quite a lot of other actors included. So you've got Clutter texture, which you just saw there, Clutter animation texture, clone texture, which, you know, animation texture should be pretty obvious. Clone texture is just a way of like preserving some precious texture memory. Then like a Clutter rectangle is just a rectangle. A Clutter label is just like a GDK label, uses pango to render. A Clutter entry is just a text entry. Then we've got various container and layout actors. And finally, Clutter Cairo and Clutter GST video, which is obviously like a Cairo canvas within Clutter, and video audio playback texture. So they're easy to subclass, and you basically combine them together to make your own. Like, they're all pretty raw, and I guess the reasoning for that is, you know, we don't want to impose any kind of like, how can I explain it? Basically, we just want to leave things pretty free because we don't want to impose any kind of particular look. The kind of applications it's for will look like very, very different. Right, and that's that. So, okay, and also, as I mentioned earlier, it handles events. It's just at the moment, it's just signals from the stage, keyboard and mouse events. You can map like a mouse clip back to an actor by the Clutter stage actor act position call. It's pretty simple at the moment, and rather than like actual actors themselves emitting events, the reason for that has been like mainly performance, and also trying to figure out like a focus model in like 3D space. We think we've figured it out now though, and we're going to add that soon. That's probably the next thing that's going to end up in Clutter is actual, you know, events bound directly to actors. But this, you know, for the kind of applications that we've built so far, this has kind of been enough. It's not bad. Okay, now, as well as actors and whatnot, Clutter has a lot of support for animations. The kind of basis of this is Clutter timelines. You basically specify a number of frames and a frames per second, you know, a rate for that timeline. And then when you start it playing, you get a callback on every new frame. And you can start, stop, rewind, that kind of thing, the timeline. What the timeline does do as well is it will actually skip drop frames. If your animation can't keep up, it will skip frames. So you can, you know your animation or whatever is going to take the same amount of time on no matter what platform. So here's a simple timeline example. If you look at like the second half, we create the timeline with 360 frames running at 60 frames a second. We set the timeline to loop. We connect a callback to the new frame signal, which is handled up the top. And all we do on the new frame signal is we literally turn the frame number into a angle to rotate it. I can show you that. So you see that's the first demo with the timeline applied. It's just rotating it. So timelines are okay. You know, they're pretty flexible. You can do quite a bit with them, but you know, you find yourself coding the same thing again and again. So we came up with a add on to this. Right, so the first thing is there's two parts to this. The first part is Clutter Alphas. Now, they're an actual function of time. They're nothing to do with like pixel alpha or, you know, pixel alpha in Clutter is referred to as opacity. What a Clutter Alpha does is it takes a timeline as a parameter and also a function, and then it produces a value between 0 and Clutter Alpha max. So you'll see on the diagram like the different functions, like a ramp just increasing over time, a sine, a half sine, and a quarter sine. Oh, there's not a full sine there. Clutter includes a load of pre-built functions for this, but you know, it's trivial to write your own. Okay. Right, now, Clutter Alphas are then used to drive Clutter Behaviors. How Clutter Behavior modifies like an actor property or like so how it modifies an actor property is dependent on the value supplied by the alpha. So it could be like a path, and then the value of the alpha would, you know, decide its position on the path. We include a lot of behaviors like opacity, rotation, depth, paths, B-spline paths, and ellipse paths. You can mix and match them, stack them up, and it's easy to create your own ones as well. Here's an example of the code. We create a timeline. We then create an alpha using that timeline with a function being a sine wave. We then create an ellipse path behavior. We then apply that behavior to the actor, and then we start the timeline. And you get this kind of thing. So we see the actor following the ellipse path, but going backwards and forth and deaccelerating and accelerating due to the sine wave. If I then pop up the code, you'll see if I then change the sine wave to a ramp, an increasing ramp, just rebuild that quickly. Then you'll see now it behaves much differently and it will stop at the end. No, it won't because it's looping, so it'll just keep going around. Sorry. But you'll see that it's not going backwards and forth. And then I can just change that back. And then I can also create another behavior, which is like a simple opacity one, going between like fully transparent and not transparent at all, and then also apply that to the actor. And now you'll see that it's fading in and out with the sine wave as well. So you should be able to see that you can like stack these together and like build up quite complicated animated UIs, that kind of thing, pretty simply. Like this is a more complicated example, but it's still only like 200 lines of code. You'll see I can like cycle through. Now this uses one timeline and a number of behaviors. Each icon has 3 behaviors attached to it. One for it to follow an ellipse path, one for it to scale, and one for it to change its opacity. And then the timeline stopped and started between each one. Like also with a sine wave, like a quarter sine wave, so you get like the nice kind of acceleration and deacceleration. And then the text changing here is also connected to that timeline, but it uses a different alpha function, which is like a a full sine wave. So when it fades out, it hooks into the middle of the timeline and changes the text. So I hope that kind of demonstrates how you can put them all together and build things like that, hopefully quite simply. The problem with behaviors and that is they can be like quite verbose, and quite a lot of code if you just want a simple effect, like you just want something to fade out or something to reappear. You don't want to have to set everything up. And for that we have Clutter Effects, which basically just wrap timelines, alphas, and behaviors into like a simple nugget, I guess. You'll see we create a template for the effects, which is basically just the timeline to use and what alpha to use, and then you can you just make the one call. Like in this case, it's scaling an actor from like its original size to 4 times its size, scaling from the center, and then you can also add callbacks for when that's finished. But that Clutter effect scale will create the timeline, start it, everything. So it's just literally one call. I'll show you the. So that's all it does. But it's it's a lot less code. That was for you, Daniel. Okay, and there's the only sort of really other solid thing in Clutter, at least exposed via the API, is Clutter Media, which is just like a kind of general interface, general simple interface for like playing back media, like play, stop, that kind of thing. But I'll talk more about that in a minute. Okay, so what I've basically discussed is like Clutter Core, and then we have various add-ons. We have Clutter Cairo, which is, surprise, surprise, a Cairo canvas. Clutter GST, which implements the Clutter Media interface to provide audio and video playback. And then Clutter GTK, which is effectively a simple GTK widget, so you can embed the Clutter stage in GTK applications. So the first of which is Clutter Cairo, which is essentially 2 API calls. Well, it is 2 API calls. It works very much like Cairo does with GDK. You basically create your Cairo context. You create a Cairo actor, get the context from that, do your rendering calls, and destroy it. And then that's basically it. I can show you a quick demo of that. So here is a demo of Clutter Cairo. Basically, it uses Cairo to render all the flowers, and then Clutter to display them and rotate them and blend them all and whatnot. But obviously, you can do a lot more with it. Yeah, all Clutter Cairo currently essentially does is just render to a GL texture. No, OpenGL is doing the rotation. Yeah, it's pretty simple in that it just basically renders to like a Cairo image. Uses the Cairo image backend and then just moves that data to a texture, which sucks a bit because it's not really accelerated. And also you have to unpremol the alpha on the Cairo data, so it's not as fast as it could be. Like ideally, there's some glitz integration to be done there, which I think will happen in the future. I did actually try that, but it never worked for me. But I've got another idea in doing it. So Clutter GST, you basically get a video texture actor, which just simply plays video. There's also a Clutter texture sync, so you can build your own custom pipelines. And also it provides simple audio playback too. I'll demo that in a minute in some of the bigger demos. And finally, Clutter GTK, which basically gives you a GTK widget which you can draw on with Clutter. And I'll just demonstrate that quickly. So, Clutter canvas in the middle, GTK around the side, and you'll see that I can manipulate that texture. These, this is just directly. And I could put some text in as well. So, pretty simple. Ooh. And some criticals. A little bit rough around the edges. Okay, so now I'm going to show you some more substantial demos. The actual slideshow program itself is written with Clutter. It's like a year old now. But, so you've seen one demo, I'm going to show you some more. They're not like really polished things, they're pretty rough around the edges. They're more like experiments with the API and just toys, that kind of thing. Hopefully they'll work all right. Just got to find where they are. Okay. So, oh, didn't see that. So this is our little table demo, which is kind of like our ghetto multi-point. I can move images around, rotate them, scale them. That's Clint. I'll find Arnold. This one's Arnold. Oh, see, it's pretty good. And then we can play video as well. Oh. Oh. And then I can scale them as well. Right. And that's in SVN if you want to play. It's only like a few hundred lines of code. It's not a lot. It was written by TF there. Right, next up is Wooha. This is just like a toy video player. It gives you like a... Yeah, they're all recorded from the BBC. It's fine. Yeah, so this is like my little toy I wrote to make a nice interface for all the free videos you can get on BitTorrent. No comment. But you can see it like filters your videos like popular, recently viewed, alphabetically, not viewed, and then obviously you can scroll through them. And then play them, seek through them and whatnot. And then see come out. So that's Wooha. That's in SVN. Obviously, the videos aren't in there. And then the next demo is Duke. But this one isn't public because we're a bit scared because it's a bit close to another company's application. But we kind of did this just to see if we could do it. So I can go like that, then I can play them and and kind of play music. Flick it out. I can also search. And that's basically that. Neil hacked that. Well, Neil wrote it in about 2 weeks, and you'd never touched Clutter before, and never touched GL or anything. No, so no, it's maybe 1,000, 500, 1,000. It just pulls the covers out of Banshee, so you know that's where like most of the work is in actually getting the metadata. Yeah. One second. Okay, there's, you know, check toys in SVN. There's some other things, but they're maybe a little bit more risky. So I'm not going to demo then. I'm going to speak a bit about the internals. So it's all fixed point maths inside, and the API has fixed and float API entry points. So every API call which uses float parameters also has a fixed version. People aren't really encouraged to use the fixed API unless they're really developing for like a device without an FPU. Obviously, it's important to us because we want Clutter to run well on embedded devices, so that's why we use the fixed stuff. Some other interesting things like I've used like pixel positioning because I'm lazy, but also you can use Clutter units, which are kind of device independent positioning. That's not like internally, it's what's used, but it's only sort of exposed a little bit at the moment. In the next release, it will be exposed a lot. We just didn't want to do it before GUID because it would have broken all the demos. Other interesting things, we have a custom pango renderer, which effectively renders glyphs to 8-bit alpha textures and then tiles them so we can write lots and lots and lots of text without using too much texture memory. This is what obviously Op's using. We also have this timeline pool, which is a custom source to... we found that we were having problems when we were running lots and lots of timelines. So we made this custom source, which works a lot better, but Emanuele did it, and he's not here, so I can't really comment that much on it. But it's quite clever. Also, like what I'm running Clutter on at the moment is GLX with OpenGL. But the Clutter backend is actually abstracted into two parts. You have the windowing system interface, which currently supported is GLX, EGL for embedded, and we also did an SDL one because we're masochists. Well, no, we did the SDL one just to try it out, and I guess there's a chance it would run on Windows, but no one's really tried. Then we also render the graphics with either OpenGL or OpenGL ES. OpenGL ES being like a subset of GL for embedded systems. Because of that, Clutter doesn't really use that much. It doesn't really do anything that clever GL-wise. It uses a pretty small amount of OpenGL. To the GL and GLES APIs are slightly different, and we have a layer called Coggle over that, which abstracts between them both. That means you can build the same code against a different backend, and it's just a recompile to run. Like one of these demos from GL to then run it on GLES, it's just a recompile against the different library. The plan with Coggle is to, it's a little bit hacky at the moment. The plan with Coggle is to like build it into something like processing, like a real nice, quite simple, still, you know, more below Clutter, quite low level, but like the processing kind of API for drawing. And also we have like runtime features detection, which is pretty simple at the moment, but as we move into later releases and do things like shaders and whatnot, you can use that to detect if a feature's there or not. Like one of the things it does at the moment is like YUV textures for video playback, and you can detect if that's supported or not. And also ES doesn't let you read data back from a texture, which is used for a couple of things. Okay, so bindings. We have Perl, Python, and Mono bindings. They're all for Clutter 0.2. The Perl bindings are pretty much taken care of because Emanuele likes Perl. I could say something nasty about that because he's not here, but I won't. Somebody, I forget his name, that's pretty bad, contributed the Mono bindings. But it seems that most people want Python bindings, and though we have Python bindings for 0.2, we don't yet for 0.3. Like, all the hard work's done. The Clutter is written to be very friendly to bindings. It should be easy to bind, and we're really looking for someone to do the Python bindings. And there's just an example of using Python. Like, I can't comment too much because I don't really know Python, but it looks nice. But we're really looking for some help there, and it should be a pretty easy task. Okay, future plans. Well, there's loads of them. It's never ending. For the next release, like I said, we want to improve the events. We want to expose more of these Clutter units, and we want to do these interface definition files, which are kind of like, you know, like Glade XML files. Though I'm not sure if we'll use XML. We're kind of looking at JSON, and also as well as defining like interface elements, you'll also be able to define like timelines and behaviors, that kind of thing. And then, you know, there's the obvious stuff like it would be nice to play with multipoint and Clutter. Obviously, we're going to add shader support. We're interested in like when GTK gets off-screen support, because obviously then we can render GTK within Clutter, which could be quite interesting. It could be interesting to write a glitz and a GDK-GL extension backend. The GDK-GL extension would allow for better GTK integration, and obviously if we did a glitz backend, that would mean we could use lots of the nice glitz stuff and also have the accelerated Cairo. Also, like I said before, we're keeping Clutter internally quite raw to be flexible, and people always say, oh, you know, where's the list widget, where's the table widget? And I think our answer to that is we want to create like a generic Clutter model for that kind of data, and then people are expected to write the view on top. And as I say, you know, lots and lots of ideas. See the to-do in the Clutter table, and if, you know, you're welcome to help out. Okay, that's it. Am I like really early? Am I right for time? Yes. Yes.
How stable is this? Should we be using it now in all of our applications?
Well, what we're doing is we're marking like odd releases as unstable. Like 0.3 is really a development release, but it's pretty good, and 0.4 isn't that far. I'd say that 0.4 is, you know, more than a good time to start playing with it and using it in places like.
And 0.2 is right out.
Yeah, don't use 0.2 now. I'd go with 0.3. It's pretty good. We'll probably release 0.4 like within the next fortnight.
Oh, really? That's soon?
Yeah.
Okay.
And it'll have no new features. It's just like a 0.3 that's been tested a lot more heavily and debugged. Because it's something that you can do quite strange things with it, especially the behaviors, stacking them up and whatnot. There is bugs in there, but we'll only find them when people really start using it.
Do you foresee this technology being a part of the platform at some point of GNOME? Well, for doing things like cover flow.
Yeah,
or,
yeah. No, it would be cool.
Whatever other neat effects.
It would be cool if it could. It's supposed to make these kind of blingy effects very easy to do, and it follows. It's very gnomey. Like the API is all gobject up, and Emanuele has designed a lot of the API, and so it should be really nice. So it would be good if it did end up in the platform.
Okay.
Lefty question.
Yeah, I was wondering about performance on ARM as opposed to x86. How does it look on smaller devices running at lower clock speeds and what have you? And I was also curious about the general memory footprint.
Well, much depends on your GPU hardware. We've had reports of people running it on with the PVR drivers on a high-end ARM and running, getting a good 25 frames per second with supposedly 100 actors on the stage and all being manipulated. But it's one of them questions that's difficult to answer. It really depends on the hardware. We've been really careful in making all the internals fixed point. We're relatively efficient with how we use GLES. It should be pretty good, but we haven't tested it heavily ourselves. We've run it on software GLES, and it seems pretty good, but we don't actually have any accelerated GLES hardware. So if anyone wants to send us some.
Cool. I think you're my new best friend, Matthew.
It's kind of gutting when you get an email from, a mystery email from someone, and they're like, oh yeah, we've run Clutter GLES, on this hardware we've got all the drivers for, and it's fantastic, and you're like, oh no, it's taken me 2 years to get this far, and then someone else has gone and tested it. But it was good to know,
Cool. Thanks.
Have you looked into a visual timeline editor like Flash or something like that?
Well, we steal a lot from Macromedia Director and that kind of thing, because in a past life I used to hack on Director years and years ago. So it would be nice to have something like that ultimately, but I don't know, we want to get these internet interface definition files in first, and then once that's all done and going, then we may look at some kind of visual editor, because it would be really, really cool. And I think you could develop quite impressive things without having to write, much code at all.
Yeah, exactly. It looks very much like Apple's Core Animation, which is going to come out in October, so it looks like you've beat them to it, pretty much.
Well, we haven't seen it yet. Clutter's about 2 years old. I had the original prototypes a while ago, and then I saw Front Row came out, and I was like, oh god, that's it then, and lost interest in it. And then we sort of picked it up again about a year ago, thanks to Ian.
It's fantastic.
Brilliant.
But yeah, I'm looking forward to seeing what core animation actually does, because I haven't found any API docs on it or anything yet.
So you have the idea of embedding Clutter in GTK pretty well covered. I think something which would be quite useful in the future when we start having higher resolution displays on desktop PCs and such is to have GTK embedded in Clutter via, I don't know, Cairo API for rendering via GL, rather than rendering to a texture, actually rendering via GL and then doing all your transformations and shading operations on that. Because that would be one path towards device resolution independence. So do you think that's possible?
Yeah, definitely. We've tried to keep things pretty flexible in the back-end separation and stuff. Like I mentioned about, it could just run directly on top of glitz and whatnot. And then if GTK or whatever is running directly on top of glitz as a Cairo renderer, then there's no reason why it wouldn't work. And we have a lot of ideas for it. There's a lot of ways we could go with it.
So does glitz render via a pixmap?
It renders via GL.
Ah, okay. So that would pretty much do it then?
In theory.
Okay, cheers.
Carlos? Oh, yeah, yeah. In terms of like rendering like a window with alpha?
Composite the result.
Like in terms of like, well, it's just in terms of like everything in the same process, or like separate processes.
Separate processes. Render, do some of the UI with Clutter, some of the UI with something else, and composite things against each other.
Yeah, that's where we want to sort of try and go. Like you can embed, like at the moment, you can embed Clutter within GTK, but we want to do it the other way as well. Embed GTK in Clutter, like the widgets and whatnot. So. I guess the sort of most obvious example is like on Apple when you get the wizards and it spins round. You like enter something and then it spins round on the cube to the next page like a notebook, but across the corners of a cube. Like that would.
But with transparency, so you don't have to, to have this very obvious square window and.
Oh, what in terms of like in terms of like actually rendering windows that aren't square with Clutter, well, in theory you can do it with the NVIDIA drivers, but we haven't tried in terms of like creating like an ARGB window. Because it's GL, you need support from the drivers obviously to render that. I think you can do it with NVIDIA, like it's something that I keep meaning to try out and that Neil hassles me to do but haven't done yet. Because this is all on an Intel chipset.
Right, thanks.
Any more?
Yeah, quickly. GTK-MM-like bindings for C++? Any plans?
If someone wants to write them.
Like Doji?
Doji has threatened to do it on a few occasions. We've just kept him too busy, I guess.
Yeah, okay. Thanks.
Next, Matthew.
Real fast. What are you planning on writing with Clutter? I mean, other than just demos?
I don't know. Like the real interesting thing for us is to run it on like embedded hardware and write some stuff there. I guess when we actually get the hardware, we'll write some interesting stuff. I don't know. Like I like Wuha. Like I wrote that because I thought it would be useful, but it turned into like it's a bit rough around the edges, because it was just like hack as quick as I can and try out the UI. I'd like to redo it and make something quite nice out of it, maybe. Yeah, I guess up till now it's been like, it has just been development of that because we're trying to get it to a point where it can be useful for them kind of things. And it's kind of there now, so I don't know, and also having the time to do it. But I'm sure, I'd like to do something interesting and a bit different. Not something that obvious that you could do with it, but I just haven't come up with that idea yet. But I'm sure we will. Matthew? Go on, hit me with it.
Yeah, so possibly I missed something. I was a little confused. I didn't really see where ETS fits into this.
It doesn't. No more questions from you, Matthew. Oh, up the top?
Yeah, you mentioned JSON for like description files. Have you thought of doing a browser plugin with JavaScript bindings?
Well, I like the idea of using JSON just for something a bit different, and it's probably quicker to write them than XML files. In terms of like JavaScript bindings, if someone wants to do them, I'd have to drag out my JavaScript manuals from like 10 years ago, and it could be interesting,
I mean, it could be a nice open source replacement for Flash for Blingy web pages, right?
Yeah.
We are going to have a last question, so because we are running out of time.
All right, it looks really cool, but like the timeline thing seems kind of static. Are there any plans for doing implicit animations where you can break in the middle of an animation and get to a new target state and it would auto do the right thing?
Well, in terms of like with the behaviors, you can change their properties on the fly. So they're kind of dynamic like that? Or do you mean more like physics-based animations?
Yeah, well, not like physics-based maybe, but you say we're at this state and we want to reach this state and, you know, use a ramp or a sign or whatever.
Yeah.
And then in the middle, you change your target.
Yeah, you just change on the behavior, like the start and end values are just properties. You can change them halfway through and it'll adapt.
Okay, that's cool.
Yeah. Yeah, yeah.
No more. 10 more minutes.
No. But, you know, it's just like, how can you create a theme engine that would like fit front row and fit like media center and that kind of thing? You know, if people want to do something like that that's more like high level, then, you know, write something on top of Clutter. But I can't see how we could make something that was like, that generic enough, you know, to like fit every kind of look. You know, and we're not sort of aiming for like, you know, desktop applications where every application looks generally the same. It's not for that kind of thing. You know, I wouldn't expect you to write like desktop applications in Clutter. You know, if you wanted to write like a load of applications that look the same and had a similar kind of theme, I'd write a layer on top of Clutter that, you know, provided that. I hope that makes sense. Sorry, could you repeat?
So I mean that, like file chooser, you had few examples how to browse in pictures or records. Have you idea that having this kind of things as composite widgets that can be used by other applications?
Well, it's like we want to make this Clutter model so it makes like doing them things easier. You know, you at least just have the programmer view. But again, I'm not sure if it's possible to create that kind of thing so it's generic enough. Like, maybe something like that will come up, but I don't know. We've got a few ideas about that. Like, we want to keep like the freedom and flexibility there, even if it means like a little bit more work. But maybe we'll create like a Clutter's Actors add-on, which has a lot of common things. I'm really not sure. But it's not that much work to create like that list view, you know. It's pretty simple.
We have 10 more minutes, so if you want to see more demos or keep asking questions, we can take advantage of that.
I just wondered if you could you show the SVN link again, the URL for SVN repository?
Oh yeah, sure. So there we go.
Thanks.
This is Clutter. This is Opt. There's a little program called Opt in Toys, and it just takes like a XML file and then produces the slides. It's pretty rough and ready, but it does the job, you know. It uses, you know, it's from like about a year ago, so it just uses timelines. It doesn't use like the behaviors and stuff. It's pretty simple.
I started using Opt and Clutter last year at Glidec, and didn't mention anything about it, but I just did the presentation at Glidec, and all of the OpenHand guys are like, yeah. And it's, I mean, just hacking on doing like extra little animations and stuff for Opt and playing around with, you know, actors and stuff like that. The code is really, really nice to work with, and if I can do it, then, you know, there shouldn't be too many other people in this room who can't do it then.
Just a slightly tangential view. One of the problems we have right now is Clutter's great and it performs very well. I have to say I have a i.MX Freescale board on which has a GPU, but there's no free software DRI for it. So this is the problem we're going to hit again and again with new chipsets which have a GPU, but there's no free software implementation of the DRI driver for it.
Yeah.
So is there any approach or a particular project you guys are working on to solve this? Because then the specs aren't open even.
No. Like this is I think what you're saying is that there's a big problem with like OpenGL, in that there's very little free software around for it, and like, even getting binary drivers for hardware is very, very difficult, let alone like open ones. Like I know that like Kronos has picked up on Clutter and stuff, so you know I want to try and pressure them, but who knows? You know, it's a real pain. But hopefully, hardware manufacturers will realise that it makes sense to open them up. But who knows? You know, and a lot of them are very buggy, and you know, it's quite depressing. LGPL. What, in terms of having like a software renderer? Yeah, it's possible. Because, you know, obviously Clutter isn't using like all of OpenGL. You could maybe write a software renderer that just used that like little subset. Yeah, it would be pretty interesting to see how fast you could get it, you know. But I just worry about then, in the future, as we add more and more GL features, if we've then got to implement them in software as well. It would be pretty cool, though. I think you could make it probably quite fast.
Software rendering to be really fast and parallelizable to itself.
Yeah, but if you can get it that fast, then you'd have like a GLES software implementation, you know, and you could just sit on top of that. But it seems that most of the GLES software implementations aren't actually that fast. And I think you could just generalize in the kind of operations that Clutter's making to make it a lot faster. Any more?
Do you have any plans to somehow combine these with Matchbox?
Well, I'd like to write a compositor that used like a compositing engine that used Clutter to do the actual rendering. And, you know, obviously that would probably end up in the back of Matchbox, but I'd really rather wait till I get Matchbox 2 written and do it there, which will never happen. The flippy video thing? Oh, what, on Wooha? Okay. Yeah, I forgot to demo something that Wooha does that Ian likes.